Well, thank you, Rich, for that very, very nice introduction. I sure appreciate your generous words. And hey, happy Earth Day to all of you. I wish that we could be in glorious Stevens Point, Wisconsin together, celebrating and appreciating the conference, enjoying a point beer. I got my undergrad in Stevens Point, so I'm pretty familiar with point beer. But I want to make sure that you guys are familiar with Earth Day. Earth Day was established in Wisconsin in 1970 by Senator Gaylord Nelson. It started kind of out of a protest associated with the Book Silent Spring, right? And DDT and all the trouble we were having with pesticides at that time. That's where it all started in Wisconsin. I first learned about it as an undergraduate student at Stevens Point. In more recent years, for example, it's taken on larger meaning and even truly global meanings. The Paris Agreement was signed by several countries in 2016 on Earth Day. I know this year, President Biden's going to be meeting with senior leaders from over 40 countries on Earth Day to talk about climate change and what we need to be doing together. So I think it's really quite apt that our session is occurring today as our topic fits the day. Healthy wildlife are needed for healthy livestock and healthy people, and keeping wildlife healthy today requires innovative management, which is our profession's collective responsibility, right? So I'm glad we're on the same team together. And I'm going to talk about diseases at the interface between wildlife and humans. Before I get into that, I want to talk about more about just the context of what is the mission of our profession. And my former director, now retired, Dr. Larry Clark, he put it with nice panache and good eloquence that in context, applying scientific expertise to resolve human-wildlife conflicts while maintaining the quality of the environment shared by wildlife is our profession's mission. And I think you put it better than I did, but kind of on the same lines, I think you can only put so many rats in the cage before it's going to get ugly. And that's kind of where we're at, right? We've got 7 billion people on the planet right now. It's climbed exponentially. We all know these exponential growth curves nowadays. It used to be just us biologist types who knew those kinds of curves, but we're at 7 billion now, projected to be at 10 billion in 2050. And what's that mean? That means that there's less elbow room for all of us. There's 4 times less elbow room on the globe for humans right now than there was 120 years ago. And with our associated demands for protein, there's more livestock, so we're elbowing out the wildlife, right? We're creating more interfaces. And along with these increases in our populations with technological advances in the last 100 years that we've made to move ourselves and to move our goods, whatever our hearts desire, whatever we want to move around, for better or for worse, we've become amazingly interconnected. This picture shows the shipping channels, the different shipping web and the amount of traffic that there is by sea. And here it is by air. It's interesting to see just how interconnected we really are. And the pandemic, the current global pandemic, as well as I guess I'd say the current Suez Canal debacle, really clearly points this out. But of course, along with moving ourselves and our food, like livestock and other goods, we're also moving pathogens, which could open up a whole nother can of worms. So for my talk, what Rich and I had talked about that he'd like me to kind of focus on, I was going to give a little talk about the bovine tuberculosis situation in Michigan, where I've done some work over the years. But as I started to get into it, started making this talk the other day, I kind of changed my tune a little bit, realizing that it's not so much a deer issue, it's a people and a cow issue. So that's the example I'm going to sort of focus on after starting out a little bit more broadly and going back in history a little bit. As you look at my panel here on the left, this is from 15,000 years ago, cave paintings depicting humans along with some kind of cervid, right? So we're starting to domesticate animals, starting to do some animal husbandry 15,000 years ago. The panel on the right there, that's just another, that's one of my beer shots. I always have with my technicians and employees, they're always trying to get the beer shot, the photograph that's so good that I'll buy them a beer for it. And this technician caught this picture of cattle, of a cow, and the deer together. Perfect interface picture. I bought them a couple. So the reality of some of the trouble surfacing at the interfaces is really, really hitting home with us right now, isn't it? With the current ongoing global pandemic, the third significant coronavirus to emerge in 17 years, exemplifies the increased risk for pathogens to jump from infected wild animals to humans. In these instances, livestock could be an intermediate host or not. So the whole reason that we can't be in person at our conference, or we want to be, is because of an issue that should be very near and dear to us. It's because of disease at the interface. And we're all familiar now with Wuhan, and here was a situation in Wuhan, in the upper left there, where you got fruit bats in cages above primates. You know, we're just inviting opportunity for evolution to occur and these pathogens to take hold and diseases to morph and change. And that's how we get diseases like COVID popping up here in the lower left. I mentioned earlier how now it's not just us who've taken population biology, population dynamics classes who understand these graphs about exponential growth and flattening the curve and things. The rest of society is starting to get it now too, because it's on the news all the time, as well as these different types of interfaces and the risks that we're taking relative to how we're interacting with wildlife, how we're doing our husbandry with wildlife, those kinds of issues. And to this end, I want to ask you, this was a surprise to anybody. Was it a surprise that this pandemic broke out? I don't think that it was a surprise. I think it was on our radar. It was on our profession's radar, right? But the importance of thinking from One Health perspective is more jugular now than ever. You know, we wildlifers need a seat at the table when the human health and livestock health professionals are talking, and decision makers are there too. We need to be right there with them. Us wildlifers, we were One Health before One Health was cool. I'd say that we stayed One Health when the buzzword wasn't as buzzy anymore, and we're still One Health. And to that point, we had started this book well before the pandemic broke out, but it took the pandemic. So my colleagues, my co-editors from Spain, they're on lockdown. I was here upstairs in my garage. It took the pandemic to get us to the opportunity, I guess, to be at a computer, finish up the book, and get it to the publisher. Now, while the wildlife and domestic livestock interface has been in existence for thousands of years, the risks of disease spillover are higher now today than in the past due to those global patterns that I was describing: increasing close contact, global trade, those sorts of issues. It's making it tougher. Thus, more multidisciplinary studies of animal interfaces, especially those involving wildlife, must be brought to the forefront so that the knowledge gaps can be realized and filled to inform managers and policymakers. In the first part of the book, we illustrate and discuss ecological and epidemiological concepts related to the interfaces, the vision towards social ecological systems health. In addition, we address the history of past animal interfaces to provide necessary perspectives to focus current questions and to help better understand the present situations that we see ourselves in, and to inform the best approaches that we can take in the future. The second part of this new book discusses the myriad of similar and differing wildlife-livestock interfaces found around the world. We reached out to authors from all over the planet to help us with this section of the book. Then we focus on how to assess spatial and temporal overlap between livestock and wildlife. We present new technical innovations about how intertransmissions between wild and domestic populations can be quantified. We give an overview of the main modeling approaches, disease transmission at the wildlife-livestock interface, and we illustrate it with specific case studies. Finally, the need for interdisciplinary approaches and a dedicated thematic field to approach the wildlife-livestock interface and create opportunities to promote wildlife-livestock coexistence is emphasized. The concluding chapter then presents perspectives and directions to better understanding disease dynamics at the wildlife-livestock interface relative to global change and implications for the future. So, comes out next month. Get yourself a copy of the new book. We start out by talking about how we humans made the issue, right? There was no such thing as livestock until we made it so. Starting about 10,000 years ago, as I look at cattle, is when the domestication started. They're all wild breeds. Then by about 7,000 years ago, there was some domestication going on to the point that 500 years ago, our domestic land races had been developed into what now are our current domestic breeds. And of course, the same phenomena was occurring with other livestock species like pigs and goats, for example, creating a multitude of new epidemiological interfaces and thus opportunities for horizontal transmission between species and new space for the evolution, emergence, and maintenance of pathogens. And we see it wherever we go in the US, you can see it wherever you go in the world. There are trends that you're familiar with that appear risky, that there's potential for disease transmission. You know, the upper center here, I got a picture of this. I think I took this in Australia, where we've got cattle interacting with feral pigs. If we were to take a picture in Europe, they'd be native wildlife that they're interacting with. Here in the middle, this is from Estes Park, Colorado, just up the hill from me here, where you've got humans interacting with elk. You've got urban sprawl into agricultural areas here in the upper left. Some more animal husbandry practices, you know, packing animals into feedlots and things, and the associated wildlife that then could be bringing disease in or taking disease out. It can go both directions, right? Lower center, you've got deer on crops. Where's that crop going? What are the deer doing while they're standing above that crop, right? Deforestation. You see all these different issues that are creating interfaces that could lead to disease emergence, diseases taking hold, right? Now, the implementation of corrective actions then is a real challenge. So we need to understand, predict, prevent, and control disease emergence at their main origin, at these animal interfaces. Detecting early warning signs at the origin of pathogen emergence is really imperative so that they can be halted before they lead to dramatic local, regional, or as we're seeing now, of course, global consequences. And this approach is likely to be much more cost-effective than trying to adapt and mitigate after the fact, which is where I and many others of you have spent a lot of our careers. So I'm thinking the wildlife is the canary in the coal mine for ecosystem health, for our system's health. So once that genie or pathogen or invasive species is out of the bottle, it ain't easy getting it back in, right? Let's talk CWD. Let's talk feral swine. Let's talk what we're fearing with African swine fever and how imperative it is that we do what we can to make sure it does not arrive in the Americas. The reality is the wildlife-livestock interface has often been neglected. So consequently, disease spillover isn't realized until it's too late. Now I'm starting to drill back down into my Michigan example, but focusing some more on cows. Bovine tuberculosis, of course, it came over with the cows. So we, European descendants of Europe, came here, brought our cows with us. The cows had the disease, gave the disease to wildlife in some areas where it became endemic. Michigan's an example of that. So the cows spilled over, gave it to deer. The deer are spilling back, giving it back to the cows. That's the history of it. And it's not just bovine tuberculosis. There's other examples. One good one, a very telling study here of really cool data, relates to brucella in the greater Yellowstone area, where in about 1825, cows first gave brucella to bison in red and to elk in blue. And since it got established in the elk, there are at least 16 times that the elk have given it back to the cows. More on cows. Just taking one state, the state of Nebraska. Panel A here with the blue vectors. shows shipments of cows out of Nebraska. So every one of these lines, where it ends, shows where a cow from Nebraska in this given year ended up. So you can see cows from Nebraska go all over the country. Panel B with the red vectors show where cows originating, where they originated from that ended up in Nebraska in the same given year. So you can see there are cows coming and going from Nebraska all the time. Let's relate that to Mexico, our neighbors to the south, where some of our bovine tuberculosis has come from over the years. All these counties outlined in yellow are counties that have had, in this given year, this was 2018, had cows arrive from Mexico. So you can see mostly the El Paso milkshed, southwestern states, but as far as the Canada border of Montana, we've had cows come directly from Mexico and end up there. And then the blue, the shades of blue counties, the darker the shade of blue, the more cattle that they've had come from a county that Mexican cattle were introduced to. So Mexican cattle could come into any of these yellow counties, and within a short time, be moved to the next county and the next county. So you can see how if they're carrying pathogens with them, there is quite a bit of risk, opportunity for disease to take hold being presented. And then when you look on these farms, what happens at that very, very local scale? How much risk is there? I already mentioned feedlots a little bit and wildlife interacting with, or birds interacting with cattle. It's the same with mammals. Here's a picture from Michigan where we've got white-tailed deer eating from egg bags, feed that's fermenting, just a perfect environment for a bacteria like bovine tuberculosis to grow in. And then this feed is ultimately then going to be fed to cattle. So very obvious way for potential disease transmission. Here's a trail cam on the bottom here, set up on a feed bunker. And in the same evening, we've got white-tailed deer, raccoons, and cattle all eating from the same space. So of course, a lot of potential here for disease transmission. And so how we're addressing these is we need to do what we can to get a better scientific understanding of these interfaces. It's essential to identifying and managing these risks. So on the left from the book, actually, is a flow chart of available disease control options and resultant assessment of diseases of shared wildlife. So we look at what some of your options are. You can do nothing. You can just keep monitoring. You can take action, continue to monitor in a very adaptive management framework, right? Where you take action and use it to inform your next action and keep going to do adaptive management. Another example of that's what we're doing in Michigan, where we regrouped here in recent years. In 2018, we looked at all the literature, and there's a lot of literature on the topic from various entities who've been working on it to see where are we at, what are our current needs, what strategies could we be trying to implement, and that's where this adaptive flow diagram comes from on the bottom. I'll talk about that more here in a few minutes. But a little bit about where we've been with this science-driven, integrative, adaptive management approach relative to mitigating bovine tuberculosis transmission in Michigan is with state and federal entities working together toward bovine tuberculosis eradication. We've put a lot of effort in at all different kinds of aspects of the issue, from the development of multiple mitigation strategies, looking at the ecology of wildlife, not just the deer either, coyotes, possums, raccoons, other potential reservoirs and vectors around those farms, taking that model, ramping up into models to help predict what strategies are going to be able to give us the most bang for the buck. There's been different legislative actions like baiting bans, banning the baiting and feeding of deer, increased hunter bag limits, studies that we've done looking at cattle wildlife interactions and really trying to quantify those. And one of our current efforts is looking into a vaccination strategy. Just kind of real quick going over what some of these tools have been. There's specific strategies implemented by livestock producers to mitigate direct interaction and indirect interaction of wildlife from coming in contact directly with their cattle or from letting wildlife contaminate feed that then goes to cattle. And we like to classify this in like 3 different broad categories: physical mitigation strategies like fencing, psychological like frightening devices, which don't have a big role, but they can play a role, and then biological. We've got some studies there that have really been pretty good for us. Kind of real quick, we've done a lot of different fencing studies over the years, but nothing bugs me more than cruising through the Michigan landscape and seeing a USDA bought, a USDA built fence with the gate open. So we also find ways so that the gates close themselves to help farmers not have to get out of the tractor and close the gate and keep the deer out of the feed, keep the deer out of the pens with the cattle in them. We've also done studies to assess the abilities of white-tailed deer to jump fences and how high they need to be. Do we need double fencing? Those kinds of studies are done to help inform policy at the federal and state levels. We've looked at relative to other but similar issues in the same areas, not always just cattle, but if the wild deer are transmitting disease like bovine TB to captive high fence deer operations, that's an issue too. And that could go both ways through the fence, right? And also applies to chronic wasting disease. We've done studies along those lines to help inform our efforts. Other work along those same areas, looking at economic impacts, potential disease transmission issues. Other things that we've done relate to like response. If there's an outbreak that happens, how can we get on it? So when we did this related to deer at the time, we were thinking about foot and mouth disease. When we did our first study relative to the same issues with feral swine, at the time we were thinking about classical swine fever. Now we're glad we did it. How often are we able to be proactive, right? Because it applies directly to African swine fever. The biological points that I was talking about, those for us have been mostly dealt with using dogs to help us manage wildlife. We've used them in crops to keep deer, raccoons, other wildlife from contaminating or consuming crops. And we've used them in pastures very successfully in Michigan. The dogs do a great job of not only preventing any predation kinds of issues, but from keeping deer and other wildlife from coming in direct contact with cows, coming into contact with feed meant for cows, like focus feed, and as well as on a bar scale, keeping the wildlife out of the pastures as a whole. For psychological devices, frightening devices, we've done a lot of tests that showed that things didn't work. Some of these are sold and marketed. We're showing that they don't work. But we've also showed that there is some potential for some of these devices. This one here on the bottom, on the right side, this device works well for protecting hay bales. Cows will come and feed off these bales, but deer will not stand for being slapped by this rotating bar as it goes around. We've also done some ecological work looking at quantifying the rates of interaction of wildlife species within species and among those species, wildlife and the livestock. These pictures here depict some GPS data that we got off of deer, so we knew exactly where the deer were, how close they were, proximity to conspecifics, and also had cameras on it, so we could then determine what kinds of behaviors, what kind of contacts were actually occurring. We've done the same thing, relatively the same kinds of work then, where we've had the collars on everybody in the neighborhood, right? We've had collars on the cows, the possums, the skunks, the raccoons, and the deer, as well as all their food sources, to see how they're interacting in space and time, and also to see how the wildlife reacts to our mitigation measures. This deer here in the bottom left is wondering, where'd this fence come from, right? Used to be able to get in and out of that stored feed facility, but we put a fence up the day prior in this case. All these data then are rounded up and used in models that can then be used to inform management. And that's kind of where we're at right now, where we've evaluated all these different tools. We have a meta-analysis going on of all the data from all the different sources, right? So we're cooperating with the Michigan DNR, Michigan Department of Agriculture, USDA Veterinary Services, colleagues from around the world who are dealing with similar issues as bovine tuberculosis occurs in other areas too with different reservoir species, right? And using that adaptive management framework, one of the things that we're working on right now that we'll be doing on the heels of this modeling effort will be a novel vaccination experiment. And we'll use that then to inform next steps to know what role that might be able to play in ultimate management. So all of our foundational research is done. Colleagues at the National Animal Disease Center in Ames, Iowa, have done all the work with the vaccine in pens. They're ready to go to take it to the field. So that means then it's our job to help get it there. So as they were finishing up those steps, we did some foundational research to realize, develop our strategies, and what we found is we can get our placebo baits 70% of the deer on the landscape. So now our goal is, and the protocol actually just got approved today, so now we can start working with getting the registration okays that it's going to take to be able to put vaccine on the environment. But hopefully by this time next year, we're giving that a try in a research context. So scaling back up, as you can see, the collective we is putting a lot of effort into bovine tuberculosis, and as a lot of you guys are involved, there's similar efforts going on with other diseases, right? Like chronic wasting disease, focusing on other systems, other focal wildlife species. We're not the only ones, and it's good to see these publication trends. So if you look on the panel there on the right, at the number of publications related to the wildlife-livestock interface, in the last 10 years, it's went up 4 times, right? So the profession is seeing this. Look at the pie chart there. Of those publications, 65% of them are addressing issues of the wildlife-livestock interface. 16% look at the human-livestock interface, and 19% look at the wildlife-human, the COVID actually interface. So all of these are going to ramp up here real soon, because there's going to be a big pulse of money and effort to start filling these knowledge gaps. And this one that's looking at wildlife human, that one will wrap up the fastest probably. To give you an idea of where these studies are being done, the darker blue, the more studies have been done, and then you can see the primary species that have been looked at and the primary diseases that have been addressed on these different continents. So most of the work to date has been done on cervids. In North America, it's white-tailed deer and elk. In Europe, roe deer, fallow deer have received a lot of attention, as have wild boar. Research production of long-term studies on wildlife diseases so far has mainly been in these more developed countries of the northern hemisphere. So we need to address that here too. But to some, I do feel that the future is quite bright. I'm amazed at human ingenuity all the time. Look at our smartphones. The first cell phone that I had to have it for a wildlife damage management job I had. It was a big clunky thing, less than 30 years ago. And now we're all carrying these computers in our pocket. A buddy, Gary White, past president of the Wildlife Society, he took me for a spin in his 100% electric car the other day. Who'd have thought that'd be possible just a few years ago? And one of the biggest advancements that's got to have us all awed, and that really applies to this very well right now, is that we're vaccinating millions of Americans against COVID each day right now with a vaccine that didn't even exist 6 months ago for a disease that didn't even exist 18 months ago. So I think we're up for it. We're up for the task. Though control and management of endemic and foreign animal diseases in North America is daunting, the future is bright, and we're up to the task. Our existing baseline and framework of global knowledge, increased cooperation and collaboration amongst countries that's being spurred on by the current pandemic, and the recognition of the importance of addressing disease issues proactively and head on, all bode well for protecting our natural and agricultural resources. And it fits us. We're wildlife disease and damage professionals. It's how we roll. We get to work, we keep working, we don't stop, we get the job done. So I think we're going to be in pretty good shape. And with that, I'd like to, I guess I can't take questions right now, but hopefully I generate some discussion. We can have some of that discussion later. Thank you very much for your time and attention.